Okay, so good afternoon, guys. Yeah, so welcome to fourth class. Yes, so this is the fourth class, and today we're going to be looking at architectural patterns in Android, right? Yeah, so of course there's a pattern to every of your application. There's a way it should be structured, because when you talk about architecture, right, you're basically just talking about structure, right? How things are laid out and stuff like that. So we're going to be looking at Android architectural patterns in today's class. And then we'll look at it from the concept, trying to understand what it is. And then, of course, hopefully we'll have time to build something just to test it out, right? So let's just get right into it, right? So architectural patterns, they are basically patterns that are used to structure the design of software applications, right? Especially in the context of user interfaces. And what do they basically do? They basically just help you to separate concerns, right? So let everything that is related to this, let them just what stay. So UI is a concern, okay, stay on your own. Logic is a concern, stay on your own, right? So that's separation of concerns. Helps you to improve your organization of code, right? The way your code is actually what organized, it helps you to improve that, right? And then of course, um, also helps you to enhance maintainability, right? Helps you to enhance maintainability. So there are two we're going to be looking at, right? The model view model, which is the MVVM, and the model view presenter, which is MVP. There are some other forms of architectural patterns, but we'll just talk a bit about these two, right? Okay, so we'll start with the MVVM, right? The MVVM promotes a clear separation of what concerns, right? And that separation of concern makes it easier to maintain the code, test your code and extend your code base. It's actually widely used, right? As far as modern user interface development is concerned. So it's actually widely used. So it's actually it divides your application into three main components. The first one is the model. Your model basically represents your data, right? Your data and business logic of the application. So it basically just holds data and exposes methods to manipulate that what data. Okay, that's just your model. Now the view represents the user interface what elements, right? Of course, that's basically the view is responsible for displaying the data to the user and then handling, user interactions, right? And then, of course, the last is the view model. The view model basically acts as an intermediary between your model and your view. So it provides data and behaviors that is required by the view, right? So whatever data that the view requires, whatever behavior that's when you talk about behaviors, talking about methods, functions that the view requires, right? It acts as an intermediary, right? And it provides that. So it actually transforms and adapts the model's data into a format that is suitable for the view to display. Okay. And of course, the view model also handles user actions and updates the model as needed, whenever that is needed. So that's just the uh, view model architectural pattern, right? It's actually widely used, and that's basically what we're going to be using, right? But let's just talk a bit about the MVP, which is the model view presenter. This is the same. This is also an architectural pattern, right? But it also promotes clear separation of concerns. That actually makes it easier to maintain, test and extend your code base, just like we talked about before, right? Now uh, it's well suited for applications that requires much more complex user interactions and event-driven behavior, right? So whereby a particular view or whatever is actually called or driven when an event takes place, right? That's event-driven behavior. So of course it's divided into the same three components, right? But apart from the last one, it also has the model, which represents your data and business logic, right? The view also, which is the user interface elements, right? And then of course the what's it called, the presenter, right? So the presenter, just like the view model, also acts as an intermediary between the model and the view. Now, but unlike the view model, right, in MVVM. The presenter here actively handles user input, right? It also updates the view and communicates with the model. Okay, so it actually makes decisions on how data should be presented in the view, unlike the view model, right? So the view in your MVP, right, is just the user interface, right? But the thing is, the view is actually passive. It doesn't contain any complex logic, right? So what it just does is that anything that has to do with user interaction, it sends it to the presenter. Okay, so that's just about the MVP. You actually use it in building desktop applications and the like, right? Okay, so so how do you actually set up your MVVM, right? So these are just steps, right? In I wouldn't say in no particular order, right? But of course, there should be an order which best friendly should start with the model there. But there are a few things that you can actually do before the other ones, right? But let's just run through it. The first thing is you need to create the model. Remember, we said the model just represents your data, right? And business logic, right? So that's actually what the model does. And then the view, right, which actually does the same thing. It's just responsible for the user what interaction. So you create your view. After you create the model, you then go ahead to create your view. Okay, so sorry about that. Let's continue. So you create the view, right? After you've created the model, create the view. Then the next thing is to create the view model, right? That's the next thing you need to now do, create the view model. So the view model, like just the intermediary, right? So you basically just define a view model class in your application. So that will hold the data and behavior specific to that view, right? Now the next thing is what implement data binding, right? That's just the next thing you can do. Implement what data binding. Of course, I'm sure we know how to do that, but we'll still get to do these things and implement a few, if not all of them, right? Of course, the next is to implement what your view model interaction, right? That's the next thing. Implement your view model interaction. So the view model interaction there just talks about what retrieving, more like retrieving and updating data, because your view model should interact with the model to retrieve and update data. So you can use the likes of dependency injection or any other method to provide the view model with the necessary model instances. We'll actually test all that, right? We'll see how that actually works. Then the view model business logic also is something that should be set up, right? So implement any business logic in your view model. Of course, this could actually involve processing data, maybe performing calculations, right? Or making decisions based on the user input, right? So that's the next thing, of course, you need to set up. Then, of course, the view model view communication. So you can use events, commands, right? Or any other communication mechanism or means that will allow the view model to notify the view about changes that require what updates, right? We'll talk about observers and all the stuff, right? And then, of course, testing is important. Um, Testing is actually important. So since your view model contains business logic, right, you should actually test it thoroughly. So we'll learn testing in the course of our journey, right? We're going to learn unit testing and the likes, right? So we'll learn how to write unit tests to ensure that the view model behaves as expected. And then, of course, lastly, is that you need to maintain separation, because the thing is this: as you develop your application, you need to ensure that separation of concern between the model and the view model and the view is maintained, right? Okay, please confirm you can hear me. Can you guys hear me? Please, somebody should confirm.
I can hear you.
Okay. Okay, so that's actually that. So maintain separation, right? You have started it, you need to what? Maintain it. best, right? You need to maintain it as best as you can, as best as you can. Okay, so let's do a bit of let's actually work this out, right? But let's just talk about just two more things, right? The advantages, right? So the advantages of your MVVM basically is what separation of concerns, right? Because MVVM separates the responsibilities of the UI, the business logic, and what data, right? And that actually makes it easy to maintain and modify your code base, right? Another advantage is testability, right? MVN actually makes it easier to write unit tests for your business logic and your data layers. So the view model can actually be tested independently of the UI. You can just test the view model without, the UI interaction, right? And also the model can be tested independently of both the UI and the view model, right? That's actually very interesting. So we have flexibility, right? Of course, your MVVM, it allows developers to modify the UI without affecting the business logic or any of your data layers. So that actually makes it easier, right? That makes it easier. Okay, and then of course we have reusability, right? Because so as I was saying, flexibility, right? Flexibility, the MVM allows developers to modify the UI without affecting the business logic or even the data layers. So that actually makes it easy. You can just make changes in your UI and then your application will not be affected. Your code will not break, right? And then of course, the last thing is reusability, right? You can reuse codes across multiple views because you've created your MVVM through dependency injection and other ways. You can actually reuse code across multiple views. So it actually makes it easier to maintain a consistent look and feel across different screens, right, in your application. Now, everything that has an advantage, of course, has a disadvantage. So what are the disadvantages of MVVM? Now, the truth is this: MVVM complexity is one of the issues, right? It can actually be more complex than other architectures, especially for small projects, right? Because and the thing is this: you need a solid understanding of data binding, right? Observables and other concepts, which of course we'll look into, right? The second thing is steep learning curve. Of course, if you're new to MVVM, you may actually find it difficult to get up to speed with the architecture, right? Because it requires a different way of thinking compared to other architectures, right? Like your MVP and their other ones. And then of course, performance overhead. The truth is this: it can actually have performance overhead due to data binding processes, right? But of course, you can actually mitigate that with good design practices, right? When you follow your good design practices and then some optimization techniques, that can actually just be what solved, right? So that's just that. Now, let's see how we can actually now just do something simple, right? Nothing so complicated, right? Nothing so complicated. Let's just uh, let's see if we can just test out the whole concept of MVVM, right? Okay, so let me share my screen. Okay. Okay, so let's go. See, so please confirm if you can see my Android Studio.
I can see.
Okay, good. So let's just do it just a very simple stuff, right? Just a very simple stuff, nothing too complicated, right? Um, let's see my tasks for today. Let's just do a simple UI, right? I'm going to just take out this. So let's follow best practices, right? So I'm just going to call it my task, extract string resource. Okay, and then I'm going to add a recycler view, right? I'm going to add a recycler view. And then, okay, can just match parents, and then I'm going to make it 0 DP. to match constraint. And then, so for our text, I'm just going to give an ID and just say task, task, let me just call it task label, right? So let's do top to the bottom of task label, and then bottom to the bottom of parents. Okay, so that should maintain. And then of course, starts, can just go to the start of parent, and then end can then go to the end of parent. So okay, so I think that's fine. So text size, let's see if we can give, okay, 24 SP is fine. So I'm just going to extract that, and then I'm just going to call it diamond underscore 24. So these are the few things we talked about, right? Let's give you top margin of can we do 24 dp also, right? And then I'll also call that just, or okay, so yeah, diamond 24. So what I'm going to do is, so your text size, right, shouldn't use diamond. Let me I'm going to delete that, right? So just, so this should be, we can just call this text size 24, right? Yeah. Okay. Not so I think that's fine. We're not going to be doing much styling here. So for the ID of the recycler view, I'm going to call this task list. Let's just call it that, right? Okay, so let's I think this is fine. This is fine. Now, of course, you've worked with recycler view before, so also need to create the item layout, right? So let's see. So I'm just going to create task item. I'm not sure I need this. It's just going to be one for now. So just going to call this text. Just going to call it text view. Oh, sorry about that. Let's just want a single text view, right? Okay, so let's do it tools text. So we get to see, you know, how what we are doing is looks like. So this is my first task. Okay, so okay, that's fine. I'm gonna give a margin of 8 dp, right? And then of course extract that diamond underscore 8, can just keep it at that. So consistency, right? If you want to say 8 dp also, you just have to be a bit consistent. For the height should wrap content. I think the width also should wrap content. Let's keep it at that, right? And then we can just add a padding, just a bit of padding, right? For dp. Extract that. Then we'll call it diamond underscore 4. Okay, so I think that's fine. That's okay. That's okay. So getting into MVVM, right? We looked at the steps, right? So this is how we're going to go about it. First of all, I'm going to create my data class, right? So separation of concern. At the same time, I'm going to create a package here. I'm going to call it data, right? And then here I'm going to create my data class. I'm going to call it task, right? So in my data class, so I'm going to just pass in, give it an ID. So a task should have an ID of int, and it should just have a title for now. So we're not going to do too much, right? A title and a string. So this is just fine. So this is our data class, right? So let's just create some of these things now. Of course, let's for our view model, right? I'm going to also create another one for our adapter. Of course, we're using recycler view. Separation of concern, very, very important, right? Okay, so that's that. Now let's create our view model, right? So I'm going to create a view model class. So I'm going to call it my task view model. Okay, so what happens is our view model extends from the view model class, right? So with that, we have access to methods and functions and every capability of the view model class. So this will bring us into, of course, you've actually played around with this, right? But we'll just talk about it. So this brings us to creating, we're going to be creating let's create a variable. And then I'm going to make this of a mutable life data, right? I believe you know what life data is, but if you don't, um, is there anybody here that doesn't know about life data? Hmm? If you don't, just raise your hand. Anybody? So basically, live data is just a data holder class that can be observed within a given life cycle, right? That's basically what your live data is. Is a data holder class, right? That can be observed within a given life cycle. So remember, of course, you should remember your life cycle. You're on create, on this, on that, and all those stuff like that. So it actually holds data, right? Listens for changes, right? That's basically what it is. You can observe that holder class, which is the live data, right, within a given life cycle. So that's basically what your live data is. So we're going to create a life data, mutable life data, right? Mutable means it can be modified, right? And it's going to be a list of our tasks. Going to be a list of our task, right? And then, of course, I'm now going to create the life data, which is or the one that's not mutable, and this is the one we're going to expose to other activities to make use of, right? So this is private, so it's not going to be exposed. It's only exposed in the context of the task view model class, right? And then life data still of lists task, and then we're going to use the get method to get so the task with the underscore. Okay, so what we want to do is that we also want to initialize a function called load tasks. We want to initialize this when the view model is created. We want to initialize this function, right? So what would this function actually do? So we just want to fetch data, right, from a data source. That's just so we're just going to fetch data from a data source here. But this is just going to be a simulation. So we now get our task, which is immutable live data. We do dot value, right? And then we want the value of that to be a list of task. So I'm just going to give some dummy data here. So an ID of 1, and then I'm just going to call this first task, right? And then do a control D to duplicate. Let's say we just change the IDs to 3, 4, and then 5. So call this a second, call this a third, call this a fourth, and then a fifth. Okay, so this is our view model, right? So we are handling the logic and everything. We're not going to put it in our activity. So our view model is going to handle that. So you can see it interacting with the data, right? The data source. Okay, so that's actually that for the view model, right? So let's set up our adapter, right? Let's set up our adapter. So here I'm going to create an adapter, and I'm going to call it the task adapter. Some people call it adapter. So of course you know how to create an adapter now, right? So but we're going to be using our list adapter, right? Because we're going to be using our diff callback. I don't know if you've actually used that before, but of course you should have, right? So our diff list adapter takes in the task, and then I'm going to pass in our task adapter dot a view model that I'm going to create, which is the task view model, view holder rather. Sorry, I say view model, right? And then it takes in a default, a callback, right? So I'm just going to call this task diff callback. We're going to create that. Is a class we're going to create, right? Okay, so first of all, let's create our view holder, right? So I'm just going to create class view holder, and I'm going to create it inside of the task adapter class, right? And then also I'm going to create this guy. Now you can the diff util, right? We can also create it inside. We can also create the class, right, inside of the task adapter class, or we just extract it to another file, whichever one. But let's just create it inside. So here you're creating it outside, right? Here you're kind of creating it inside. So whichever one. So we can actually just do that inside. Okay, so let's move on. Okay, so our task view holder, right? You know the drill, right? You know the drill. So we're going to pass in. So I'm going to be using binding, right? Um, we're going to use data binding. So I want to use it in our task item. So I should be able to see it, but of course I can't see that. And the reason is because we haven't converted this to use data binding. So I'm just going to convert to a data binding layout, right? And we don't need this for now. And then with that, we should be able to access. So that's task item. So yeah, so that's get the task item binding. Please, at any point you need any form of clarity, please let me know. Sorry about that. Sorry. Okay. So at any point you want to ask a question, please let me know. Okay, so let's finish off with our yep. Just want to set this up. Okay, so our class view holder, right? So task view holder. Now this is going to return our recycler view dot view holder, right? And then of course, so what are we going to pass in here? We're going to pass in binding dot roots, right? Right. We're going to pass in the roots of the layout, and then let's create a function to bind. So what do we want to bind? We want to bind a task. Let's use this, right? And then I'm just going to now say binding dot so let's see. Okay, we didn't give this so an ID. So let's give it an ID. What do we call it? Title or task. A task title. Okay. Okay, so binding dot task title, right, is now equal to what task right? Which is our object dot what title. Okay, so binding dot task title dot text. Right. Thank you. Okay, so these are these for our task view um, holder, right? This for our task view holder. Like I said, if there's any question, please, just you can use the chat, right? You can use the chats. Okay, so the next thing is let's see, what do we do next? Okay, so we have some other methods that we're going to need, right? Our create view holder, we need to override those methods, right? We need to override those methods. So let's see. So let's see if we're missing anything. So class a task adapter, which takes a task, and then task view holder, right? Okay, so okay. Okay. So I think we're missing out something because okay, let me do something. Okay, that's fine. All right. Okay, so it actually is not prompting us to override some methods. So let's see if we can do that. So first of all, let me be sure that our list adapter, let's see if we can fetch the documentation there. So it takes task, right? And task adapter, which we already have. Okay. Okay. So let's see. It should have prompted us to um okay, so for some reason it's not prompting okay, I can see your message, Sultan. Okay, so as for some reason, let's see, it's not prompting us to implement the members, right? It's not prompting us to do that. Let's see if I can forcefully. Okay, it's not prompting us yet. So let's see. What are we missing? What are we missing? Okay, so let's take this out and then so it should actually prompt us. So let's take this back a notch, right? So yes, so it's the particular list adapter class that we're using that's the problem, right? So you shouldn't use this first one, which is the Android.widget, right? You should use the Android.recyclerview.widget, which takes in we can pass in our task and the view holder, right? Yes, so that's actually that. It shouldn't actually call this way, but let's just finish that up. Or I can actually okay, let's just and then let's see. So we get in our list adapter. Okay, uh, which takes in a task, and then we say our task adapter, right? Dot. Okay, hold on. Let me see if I still have this. Okay, good. Dot task view holder, right? And then we pass in a diff util. It takes the diff callback, right? Takes a diff callback, takes a diff callback. So like I said, the issue was the particular import, right, that we were making use of. That was the issue. The imports, we're importing the wrong library or the wrong dependency. So let's go. So it takes a diff util. So let's call it task diff util. So basically, right, the diffutil class, right, what it actually do is that it calculates the difference between two lists, right, and updates a recycler view with the new data. That's basically what the diffutil class does, right? So when you first of all put up your list, right, display your list in the recycler view. Let's say you make a modification. Let's say you search for something, right? So it actually gives the difference between the original list and the new list that should be generated when you search. Because when you search for something, right, it will actually return a list. Whatever action you do, it returns a list, even if it's just one item that is displayed. So it calculates that difference and then sends it right to the recycler view, right? So it's actually very useful for improving the performance of recycler view. So it's actually what we're going to be using. So I know you're probably used to the previous way, but this is what we're going to use. So yes, that's that. So that's why we need to be very um okay. So let's put that inside. Okay, so now we have this prompt to implement the members. So we're gonna do that, right? Okay. So we're good to go. We're good to go. So that's why it's very good to pay attention to the minor things. The only thing that was just disturbing us was the wrong input. Okay. So of course, you know you're on create view holder now, right? So I'm just going to this create view data, that's where you handle this, your views. So I'm going to use our task item binding, right? Dot inflate, and then we're passing our layout inflator dot from, and of course we're passing our parent dot context, and then parent, and then false. And then what do? Just return our task view holder, and then return our binding object. Okay, so binding variable. So for the let's take this guy down here. Okay, so then for our unbind view holder, which is where the whole binding stuff happens, right? So what we're going to do is pretty much easy. Just going to create a task variable, or and then I'm going to use the get item. Sorry, just get item, right? And then I'm passing the position, and then I'm going to now use my holder to gain access to my task view holder, which gives me access to the bind function, and then I'll pass in the what task. That's basically that. Now for the diff callback, right? So I've told you what the diffutil class does. So how do we implement it? So first of all, it inherits or it extends the diffutil class. So we use our diffutil.item callback, which you now pass in a task, right? And then of course your parentheses. So you also have to implement some members here, which is a check. First function checks if the items are the same. So if the items are the same, right, what happens? It will just return the old item, the ID of the old item, right? And then the new, so to return true or false, right? So if the old item, the ID of the old item is the same as the ID of the new item, so it returns this function. So it will return what's true. It also checks if their content is the same, right? Checks if the content is if the contents are the same, rather. So basically just return old item equals new item. Return that check. So if this is true, right? If it's true, it will now give you the same list. If the contents are the IDs, the items are the same, it gives you the same list. But if it's not, right, it returns what a new list to you, right? Which is dependent on the what's it called? The whatever parameter. So let me still deep dive a bit, right, into how this utility works and even why it's important, right? So see, here is the problem. When you're updating the data of your recycler view, right, that is the adapter, when updating the data of your recycler view adapter, right? You usually call this function, this method, notify data set changed. Or you check there's other methods like the notify item inserted, notify item removed, notify item changed, right? Now, these methods actually work, they are fine, but they can actually lead to some unnecessary view updates. And unnecessary view updates impacts the performance of your code, especially if you're dealing with a very, very, very large list, right? So that's basically why the diff util, that's the problem. Now, in calculating differences, right? What the diff util does is that it calculates the difference between two lists, the old and the new, and it figures out which items have been added, removed, or moved, and whether their contents also have what's changed. So it actually does this calculation with an algorithm that is more efficient than your normal brute force comparisons, which is what other methods actually what do, right? So that's what it does here, calculating what difference is. So here it checks if the items are the same and it returns a true or a false, right? Now, about the callbacks. To actually use your diff util, right? We extend what we call the item callback, right? Now, this class, right? This item callback, right? It defines how to compare your items, defines how you should compare what's the items in the old list and in the new list. So that's why we're overriding basically these two methods. There are other methods you can override. If we use the diffutil.callback, if we just use the diffutil.callback, there are methods like the get old list size, get new list size, and the likes. But we're just going to make use of these words too. So how does this do? So after you create your callback, right? It does this. So you just return your old item with if the ID have changed, right? So if the ID has changed, that means it populates that as a new list, right, and updates the word adapter. So that's just basically how that works, right? Okay, so let's move on. We are done with our task adapter, right? So let's go to our activity now, and then get to implement this, right? Let's actually now implement this in our activity. Okay, so I'm going to create a late init variable, private late init var of binding. We're going to still get into binding. Actually, we'll really talk about it, right? As okay, so I don't think I have. Yes, I've not converted this to a binding layout. So converted that to a binding layout. So we're still going to talk about binding, right? One of the things I feel from an intermediate perspective is not just being able to write your code, but do you understand how that code works? Do you understand the principles behind it and stuff like that? So we'll still take a step back and talk about binding, especially when we have to implement it in our class, in our task, right? And in the app we are working on, which is the notebook application, right? Okay, so and then how do you implement that? So for the view models, I'm going to create a view model variable. I could also do an init, late init though, but let's just do this, right? And then this is going to be of type task view model. And then we use the by view models. Okay, I hope I have the necessary dependencies for this, right? So okay, let's move. Okay, okay, let's okay, I'll fix that. Then so this is just you injecting that, well, I've not actually I don't want us to get into dependency injection. So for now, let's just do a late init, right? Okay, but we'll sort that out. Let's take things step by step. Okay, so setting this up, right? This is just our normal binding setup. So binding cross to activity, main binding, right? So it inflates, and then you pass in your layout inflator, right? Of course, your set content view now becomes what's binding.root, right? Okay, so let me get, so my adapter is going to be task adapter, right? Also view model, let's just do that, right? And then so with my view model, right? Before then, binding dot what was our recycler view name, which is tasklist dot adapter, is what adapter. Of course, you know all this, right? So our view model dot our task, right? Remember from our list of tasks, right? So probably I should have called these tasks. Yes, so it should be tasks, right? So because this actually exposes it for other classes to assess. So ViewModel.tasks, right? Dot observe, right? So we're going to now be observing what changes, right? So just going to say this, right? Which is context, and then observer. Let me just use a variable, right? Which, and then I'll just say adapter. So this is dot submit what list, and then I'll pass in what list do we want to submit the tasks, right? Okay, so another thing, yeah. So that's basically that. One last thing I just want to do is to uh, define our data variable here, right? Um, uh, should we do it here? Okay. So let me just call it a view model. Like I said, we'll really do a deep dive on data binding, right? It's not really, it's basically view model setting up that we are doing, but we're going to, so comes an example, just getting straight to my view model. Okay. So with this, right, with this variable, you can actually perform straight up, what's it called? Calculations or straight up execution of stuff, right, on your XML with this guy, right? I could decide that, let's say, let me create, I'll call this task size, right? And what's it called? Uh, let's take out this text. So basically, okay, let's put that back. So what I want to now do is the text here is going to now be, okay, so I think, let's see if I can remember the stuff. View model dot tasks dot size, right? So with this view model variable, you can actually have you can call certain methods directly, right, and to update, right? But I say we're not going to do we're not doing data binding now, right? But this is just basically that. So this text here, let me change the let's probably just put it somewhere here. Constraint up. Okay. Okay. So let's just assume it's somewhere there, right? So how would it look? Let's see how it would look. Tools, text. Let's say 24. Okay. So yeah, so that should give us access to the size, which of course, from our data, it's how many tasks? Five tasks, right? So that means when we test that out, we should have 5, right? Okay, so let's see. So let's run this now. My monitor is a bit slow, right? So while that is going, while that is actually running, while we're testing that out, do you have any questions? I think this is where you can ask questions now. Yeah, I think I'll take questions now while this is running. So Sultan,
Okay. I wanted to ask about list adapter and recycler adapter. Like, what's the difference? Because I've always been working for list adapter. I use recycler adapter mostly.
yes. So one of the things we said is right is that in when I talked about the importance of using, excuse me, the list adapter, right? Now your
Mhm.
regular when you're using your normal recycler view dot adapter, actually your list adapter is a subset of that. You get to use methods like notify data sets changed and some of all these methods. And the truth is this: those methods, they actually update your views unnecessarily, and they're actually heavy operations, right? They're actually very heavy operations. So just think of it like when we transition from find view by ID. In fact, we had Kotlin extensions, right, where you can access the ID of a view just by calling the name, right? So we now
Yeah.
move to find view by ID, and then we moved to view binding, and then we'll go to data binding. All these things, the major reason for changing them is what we call is just performance optimization, right? By the way, I just saw something on this code. We shouldn't have this val here. Well, okay, we could have just used this and initialized this. Okay, but that's by the way. So it's more of a performance what optimization technique, because if you check online, if you read about notified data set change, it's actually a very heavy and costly operation.
Well, I don't use notified data settings for my recycler. I use
You use what?
um I use default fallback for my recycler view. I
You
don't use
use what now?
notified data. I use default fallback for my
Sorry,
recycler view also.
I didn't get. You use diff util.
Yes, yes.
Okay, so no, that's also fine. The thing is, list adapter, right? We can also use your recycler view stuff, right? But is our list here is not much. We don't have a very complex list, so going to use that is just an overkill. You can also use diff util for recycler views now. Your recycler view dot adapter. Well, actually, that's what you even use. We'll use that in our notebook app, right? But this is just me playing around, just a simple example, and I don't need to go that far. It's just like if you're building an application where you're just going to display, let's say, just 3 items, there's no need going too far to use recycler view. It's an overkill, right? You just like, for example, um you've used the spinner, right?
Yeah.
When you want to load your items, you understand, you just
Yeah.
call the adapter class there. You don't need to go and do any special thing. So it's just a little what's it called, little test we're doing here. But of course, in your notebook app, we're actually going to use recycler. We're not going to use list adapter, right? You're definitely not going to use list adapter. Okay, I is that okay? Do you have any other question? Like I said, my still showing the other one. My later is a
Oh,
bit
this
slow.
application, I run it on my phone, and when I try to change it to landscape, it just crash.
Sorry, you run.
This application, this movie,
Okay,
you are,
did you
when
make
I try,
have you watched the video? Did you make changes, right? Because in the last class, right, while it wasn't running, uh we created a function, but we didn't call it.
um,
Yeah, we created a function, but we did not call it. I think I fixed that in the video I now uploaded, right?
No,
So
it was running, but when I tried to change the last week, it's only crashing when I tried to change last week.
okay, so well, we need to debug that now. We can probably maybe in one of our sessions outside this class, right? Because I usually
Okay.
have sessions outside our normal classes. We can just check that out and see, why it's crashing. That's where your lockout comes into play.
Okay.
Okay, so let's see. Uh, so okay, I think we're having. Hold on. So let me just take this out because I know I was just trying to explain something. So let's get to displaying the actual list first. Okay, we're done with this app. This app should leave us alone. Close up. Thank you very much. So, sir, I think I should fix this emulator issue by next week. It actually drags. It's actually dragging. Okay, so but uh we had an error on that particular guy, and I think I know why. So, like I said, we're not really in a data binding class, so I don't want to go to I want to stay on course. So basically this is just MVVM, right? Setting that up, and because you're now going to set it up on your, which is part of the task for your week on the weekend. You're not, so you're going to I'll still put it up right on the learning management system, right? So but you have to create a new branch, right? Which you'll call FT um maybe call it FT MVVM, right? And then set up MVVM on your code, right? You don't need to worry about if you've created you can use dummy data, right? Yeah, that's fine. You can use dummy data. So we'll get to see how your um, notes are showing, right? You get to see how your notes are showing. So you can use dummy data. Okay, so but that's basically that, right? Just kind of waiting for this to load up. Like I said, sorry about the delay. But any other question? And then, of course, I'll also push this code to GitHub and drop the link for you guys on the Discord so you can have this. Any other question? If we can, Sultan, are you good?
I'm good.
Okay. Kingspan, are you good?
Yeah. I have a question. More like an observation. Can you hear
Okay.
me?
Yes, go ahead.
Okay, so I saw how you initialized your data binding in your main activity. Can you go there? I think you did it the way it's supposed to be done when you're using view binding. I don't know if they can be done the same way though.
Okay. So you mean this?
Yes, I mean that. I was thinking to be like data binding util dot. I think that's how last time I saw it, sure.
Yeah,
But
this
this
view
way is
model.
actually for okay, this is view binding
Yeah,
one.
yeah. If you want to do, you do data binding util dot inflate. Yeah, you're right.
Okay,
Yeah.
okay,
So like I said, I'm just trying to assess views, so I'm not really stressed about, and that's why
okay.
that guy crashed. When we get to data
Okay.
binding, we'll follow. I just need to assess the views. That's all. Yeah. Okay. So Okay, it's installing. Uh, taking longer than usual. Taking longer than usual. Um. So sorry guys. I'll fix this. I'll fix this. As soon as possible. So let's check our lockout. Hopefully we don't have any error. Okay, so yeah, so we can't see our lists. So what are we missing out? Um, okay. Oh, okay. Hold on. Okay, so in our recycler view, okay. So we're missing out the layout manager, right? So let's do that in the activity. So I'm just going to say binding dot task list. Dot layout manager. So we're going to use the linear layout manager, and then of course we'll pass in the context, which is this. Okay, so yeah, that should actually work, right? So this is just a simple application, right? So we just initialize our view model here. So first of all, we started by creating our model class, right? Which takes in an ID and a title, and then we create our task view model, right? Where we create our mutable life data, right? Which we are going to store, the data. And then, of course, this is just in the context of the task view model class, right? That's why it's private. And then we expose it, expose the live data using the get method, right? So we now expose it for use. And then, of course, we are initializing this task, right? Once the task view model is created. So of course, you could call it here before your onCreate function, right? We could actually just do that here, right? Right, we could actually just do a, let's say, let me just do this, private. We don't really need to call it private, but let's just say val view model, right? We could actually just, do that there. Right, and then, okay, so this just initializing it right before creating the function, so we can actually call the load task, right? Right, so that's basically that. And then, of course, this should work. Let's test this out. So there are, of course, there are a lot of other ways you can, initialize your view model, right? Of course, you can use the by view models, which is what we will be using moving forward. But it's just a simple application just to test out the whole MVVM pattern, right, which we have done. Created our model, our adapter, and of course our view model class that has the logic, right, handles the logic and every other thing, right? So that's basically that, right? So let's see if we're able to see our list of tasks, right? Let's see. Okay, so we'll have to reinstall and restart. So just give it a few seconds. Yeah. Okay, so that should come up anytime soon. Okay. Oh, so I think so let's run that again. Okay. Okay, yep, let's see. Sorry, emulator is actually a bit slow, but I think we'll fix that. I will fix that for the next class. Okay, so yeah, we can see our list. We can see our list of tasks. So I think that's going to be all for today. Thank you very much. We're going to meet in our next class, and that's going to be on Wednesday. So see you and have a wonderful weekend.